afternoon. Today's workshop is going to cover conversions, area, perimeter, and volume. So our intent today is looking at converting units of mass, capacity, and length, converting units of time, calculating the perimeter of 2D shapes, calculating the area of 2D shapes, and calculating the volumes of cubes and cuboids. So when we're converting unit, the main units that we deal with on a daily basis, which are known as metric units, are units of mass, so grams and kilograms, units of length, millimetres, centimetres, metres, and kilometres, and units of capacity, so millilitres to litres. The first one that we are going to look at today is units of mass. So when converting between units of mass, it's really good to remember that there are 1,000 grams in 1 kilogram. So the more thousands that you'll have, the more kilograms that you're going to have. So an easy way to look at it when you're going from grams to kilograms is to think, say we've got 1,560 grams here. The 1 is your thousands, and that will go before your decimal point. So as we can see here, we'll go before our decimal point. Our 560, so in our hundreds and tens, this one goes after the decimal point. So 1,560 grams to kilograms would convert to 1.56. So your thousands is always the number before the decimal point, and that works the opposite way as well. So imagine you've got 1.25 kilograms and you want to convert that to grams. So the 1 tells you, or this number before the decimal tells you how many thousands you have. So we're going to start with 1,000, and then the number after tells you how many hundreds and tens you've got. So your 25 converts to 250. So 1.25 kilograms to grams would be 1,250. So we're now going to have a look at seeing if we can convert them. So what is 4,500 grams to kilograms? So how many thousands do we have? That will go before our decimal point, which is 4. So we're going to write 4 points. And then our number afterwards is 4.500, but we don't need our decimal points. We don't need our zeros, so it'd be 4.5 kilograms. Okay, what would be 2.65 kilograms to grams? So the number before the decimal point tells us how many thousands we've got, which is 2. And our tens, so 1650, tells us how many hundreds and tens we've got. So we've got 2,650 grams. Okay, let's have a look at the other two. So we've got what is 0.61 kilograms to grams. So we've got no thousands. So our answer is going to be in the hundreds. So this is going to be our hundreds number. So it's going to be 610 grams. And then last, what is 240 grams to kilograms? So we've got no thousands. So we've got a 0 in front of the decimal. And then our remaining number are tens, hundreds and tens, and 0.24. So remember, when you're converting from the thousands to the decimal, the number at the front will be before the decimal point, and then the numbers after will come after the decimal point. If they are zeros, you don't need to add them. Then the opposite way, if we've got a decimal and we want to convert it to grams, the number before is going to be your thousands, and the numbers after will be your hundreds and tens. And that is exactly the same when it comes to units of capacity. So when converting between units of capacity, remember there are 1,000 millilitres in 1 litre. So exactly the same premise. Say we've got our thousands number, our front number goes before the decimal, and our numbers after go after the decimal. Same on the other side, so say we've got a decimal here. Our number in front tells us how many thousands. We've got no hundreds, so just tens. So it'd be 5,550. Okay, so let's have a go at some of these. So what is 6,500 millilitres to litres? So we've got 1 in the thousands, we've got 6 in the thousands, so it's going to be 6 point, and then whatever after, we've got zeros after here, so it's just going to be 6.5 litres. Then we've got what is 2.35 litres to millilitres. So we know we've got 2,000, and then the rest is going to be 110, so 350 millilitres. Okay, and our last two. So what is 0.41 to litres? So we've got no thousands, so our answer's going to be in the hundreds, so it'd be 410 millilitres. And then what is 210 millilitres? So we've got no thousands, so we've got nothing before the decimal point, and then 21 litres. Okay, and that is converting units of capacity and mass. Our next that we're going to look at is converting units of length. So in the metric system, we deal with millimetres, centimetres, metres and kilometres. When we are moving from small measurements to larger ones, we divide in sets of 10. So to go from millimetres to centimetres, we divide by 10. To go from centimetres to metres, we divide by 100. To go from metres to kilometres, we divide by 1,000. And then when we go the opposite way, we then multiply. So from kilometres to metres, we multiply by 1,000. Metres to centimetres, we multiply by 100. And centimetres to millimetres, we multiply by 10. So let's have a look here. So we've got 30 millimetres, and we want to go to centimetres. So we're going to divide by 10. So 30 divided by 10, we can knock off a 0, and we're left with 3 centimetres. Okay, we've got 20,000 metres now, and we want to convert it to kilometres. So now we're going to divide by 1,000. And another way of dividing by 1,000 is we can knock off 3 zeros. If we didn't have the right amount of zeros, we would put a decimal point here and hop back 3 places. So our answer would be 20. And then finally, we've got our 4 metres. So we're starting off with metres. We're wanting centimetres, so this time we multiply by 100. 4 lots of 100 is 400 centimetres. And that is how we can convert units of length. Then our last conversion that we're going to look at today is converting between units of time. So what's important to remember, there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So say we had 70 seconds, and we wanted to know what that was in minutes. We know that 60 is 1 minute, and what do we have left over from 60 to 70? It's 10 seconds, so it would be 1 minute and 10 seconds. Okay, so let's have a look. So we've got 126 minutes to hours. So we know 60 minutes is 1 hour. And how many 60s are in 126? So we've got another 60 minutes, which is another hour. So that's 120, and then we've got 6 minutes left. So it'd be 2 hours and 6 minutes. Okay, what is 2.5 hours to minutes? So here we know that the 2 is 2 lots of 60, and then we've got 0.5 hours. So what's another way of saying 0.5? Well, it's half. So what's half an hour? Well, we know 60 divided by 2 is 30. So we know we're going to do 60 times 2, which is 120, then add our 30. So 120, add 30, and we're left with 150 minutes. And then next we've got what is 10.5 minutes to seconds. So we know there's 60 seconds in a minute, and we want 10, so we're going to do 60 times 10, which is 600. And then you've got 0.5 of a minute, or half a minute, which is 30 seconds. So we're going to do 600 add 30 seconds, which is 630 seconds. And then finally, we've got 112 seconds to minutes. So we know 60 is 1 minute. What's left over from 60 to 112? So it would be 52 minutes, 52 seconds. So that would be 1 minute and 52 seconds. Just take a little bit of adding, subtracting, and knowing your decimals as well is super important. So now we've converted units, we can now come on to calculations with shape. So perimeter means the total distance around the edge of a shape, and you calculate this by adding amounts together. So for example, here we have a rectangle, we have a compound rectangle, and we have a triangle, a very special triangle, which is known as an isosceles triangle. And all we do here is we add the sides together. So we know a rectangle has two pairs of equal sides. So we know that this is going to be 6 and this is going to be 3. So to work out the perimeter, we do 6, add 6, add 3, add 3, and we are left with 18 meters. Then with an isosceles, these lines mean the sides are equal. So here it's going to be 3. So our perimeter of our isosceles triangle is going to be 3, add 7, which is 17 meters. And then finally, we have a compound rectangle, but as you can see, we have sides that are missing. Now, to work out these missing sides, you need to look at the side that is in the same direction. So here, we know that all the way down is 7 meters, but we know from here to here is 2 meters. So something added to 2 or 7 take away 2 gives us our missing length. So 7 take away 2, which is 5. So we know our missing length here is 5. And we do exactly the same to the opposite direction. We know all the way across is 9, but from here to here, we don't know. But here to here is 4. So we know 9 take away 4 will tell us our missing length. 9 take away 4, and that gives us 5. So now we can work out the perimeter. So we're now going to do 4, add 7, which is 11, add 9, which is 20, add 2, 22, add 5, which is 27, add 5, which gives us 32 meters. And we have got our perimeter. Now, sometimes you might be presented with what we call problem questions. So say a question asks you for something where it's around the outside of an object. We calculate, so for example, things like fencing, or like fencing your garden or putting hedges around. So say a question said James needs to fence his garden, which is 14 meters. Each panel of fencing is 2 meters wide and costs £12. How much will it cost to fence the garden? So we calculate this by working out the shape's perimeter and then dividing it by the width. Now we know here that the perimeter is 14, but if we didn't and we had to add all the sides together, that's how we would calculate the perimeter. So we know it's 14 and we're going to divide that by the width of the object. So that might be fence panels, hedging, gating. So here it's 2 meters wide. So we're going to do 14 divided by 2, which tells you how many panels. So James needs to use 7 panels to fit around his garden. Now, to work out the cost, we multiply how many panels he needs by the price of each one. And we know here they cost £12. So we do 7 times 12, and it's going to cost 84 for James to fence his garden. So we do perimeter divided by width to tell you how many of the object you need, and then multiply that by the cost to tell you the total. So let's have a look at this question. Jenny wants to fence her garden. Each fence panel is 2 metres wide and costs £12. Calculate the cost of fencing Jenny's garden. So step 1, we're going to work out the perimeter. Now this, we don't have to go all the way around because it's her garden. So this would be the walls of her house. So we're only going to work out the part she needs to fence. So we're going to do 4, add 5, add 3, add 6. So 9 add 3 is 12, add 6 is 18 metres. Then we're going to do the perimeter divided by the width. So we know the perimeter is 18. And we know each fence panel is 2 metres wide. So we're going to do 18 divided by 2, which tells us we need 9 fence panels. And then step 3, we're going to work out the total. So we know that they're £12 each. We need 9 of them. Sorry, I've just written 19 because I said 12 and 9. 12 each. We're going to times it by 9. So 10 times. So if you wanted to break that up, you could do £10 times 9, which is 90, 2 times 9, which is 18, and you are left with £108. And that is our answer in our 3 steps. So we work out the perimeter, we do the perimeter divided by the width, and then we work out the cost. And that is perimeter problem questions. So now we're going to have a look at area. Area describes the amount of space inside a shape, and it's always measured in squared units. So for example, centimetres squared, metres squared, inches squared, or feet squared. It's always measured with a little 2. We calculate it by doing the length times the width. So for example, here we would do 6 times 3, and that gives us an area of 18 metres squared of that rectangle. So what I would like you to do for me now, I would like you to calculate the area of the 4 shapes. So remember, it's the length times the width. Have a go at those now. Okay, let's have a look at some of these answers. So our first one, we're going to do 8 times 3. That leaves us with 24 squared centimetres or centimetres squared. Our next one is 5 times 7, which is 35 feet squared or square feet. Our next one is a square, so we know it's the same length, 3 times 3, which is 9. And then our last one is 10 times 4, which is 40. So it's literally just the length times the width, the 2 numbers multiplied together. So sometimes you might have to work out the area of a compound rectangle. So when calculating compound rectangles, you must split the shape into several pieces, work out the area of each, and then add together. So here we're going to split it down the middle, and we're going to call this shape A, and we're going to call this shape B. Now, as you can see, we are missing a length, which is needed to work out the area. So we know that this part and this part is 4 and 2. So 4 and 2 altogether must be 6 centimetres. So now we can work out the area of shape A, which is 6 times 5, which is 30 centimetres squared, remember, and then the area of shape B, which is 4 times 2, which is 8 centimetres squared. So then the total would be 30 add 8, which is 38 centimetres squared. So you split the shape, you work out each, and then you add together. Okay, so say we had problem questions. So say a question asks for things like carpeting or something to do with inside a specific area. So James needs to carpet his living room, which is 14 metres squared, and each carpet tile has an area of 0.5 metres squared and costs £6. So how much will it cost? So here we're working out how many carpet tiles is needed to fill his living room. So that's what it's telling us. So we calculate the cost by dividing the shape's area by the area of the object. So if it isn't given to you, you might have to work it out first. So length times width. And then we divide it by the area of the object. So we're going to do 14, which is our area, divided by the area of our object, which is our carpet tiles, is 0.5. And that tells us we need 28 carpet tiles. And then to work out the cost, we multiply how many of the object we need, which so here is 28, by the cost of each one. So 28 times 6 tells us it will cost £168 to carpet the area. There are some shapes, which I'm going to show you now as a problem question, where you might have to work out two different shapes and then do something different with them. So for example here, one problem question I want to go over with you is where we have what we call a compound shape and you have to take one away from the other. So a decorator is painting a room and has one wall left to paint. They have enough paint to cover 12 metres squared. The dimensions of the wall are shown below. She will not paint over the door. So here it's saying we don't need to know, or we don't need the area of the door. But if we just calculated the main area, we're including the door in it. So what we have to do is we have to work out the area of the wall and then take away the area of the door. So our area of our wall would be 4 times 3.25. So we'd be able to use a calculator here, which would be, pop that in, 4 times 3.25, which is 13 metres squared. And then we're going to take away the area of the door. So 0.9 times 2, which is 1.8. And that leaves us the total to paint. Take away 1.8, which is 11.2 metres squared. The question says enough to paint 12. Do they have enough paint? Use figures. So no. Oh, yes. Sorry. Yes. The area is 11.2 metres squared. So there will be spare paint or 0.8 meters, because that's the difference between 12 and 11.2. There we go. And that's our problem question 1. Our second problem question is the following. A man needs to paint the wall behind the bunk bed with a different colour next to the bed. The lower level will be painted green. He needs to work out the area of this space. What is the area that he will paint green? So we have here a compound shape. So we're going to, method 1, we're going to split the shapes. We're going to work out any missing lengths. We're going to work out the area of each. And then we're going to add together. Okay, so let's split the shapes first. So we split the shapes. Perfect. Choose a different colour. Might have to stick with red. So we've split the shapes. Tick. We're going to work out any missing lengths. So we know all the way across is 1.95, but from here to here is 95. So we're going to do 1, take 1.95, take away 0.95, and that equals 1. So 1 metre is the missing length. And we've done step 2. Now we're going to work out the area of each shape. So we're going to do shape A. Let's call that A. And let's call that B. So A would be 1.3 times 1, which is 1.3 metres squared. And then shape B would be 0.95 times 0.5. 0.95 times 0.5, and that is 0.475. We're going to add those two together as our final step. Sorry, my pen's a little bit broken at the moment. So we're going to do 1.3, add 0.475, which gives us 1.775 meters squared. And we've done all 4 steps. Our last topic that we are going to look at today is what we call volume. Volume is the amount of space inside a shape, and it's measured in cubic units. So, for example, centimetres cubed, metres cubed, inches cubed, and feet cubed. We calculate volume by multiplying the length times the width times the depth. And we have 2 different shapes that we're dealing with. First, we have a cuboid, which is a 3-dimensional rectangle. Okay, like a box. So, say our length was 4 meters, our width or our depth was 2, and our width was 4 meters. So we're going to do the volume would be 4 times 2 times 4. So 4 times 2 is 8 times 4, which is 32 meters cubed. Okay, next we have a cube. And what do we know about cubes? All the sides are the same. So sometimes you might be given just one length with a cube. So here, say we've got 3 centimetres. So here we're going to do 3 times 3 times 3. So it would be 3 times 3 is 9 times by 3, and our answer is going to be 27 centimetres cubed. And that is how we work out the volume of cubes and cuboids. So we multiply the length, the width, and the depth. So I want you to now have a go at calculating these 3 cuboids and cubes. We've got 2 cuboids and a cube. Okay, let's have a look at some of these. So our volume would have done 4 times 3 times 6. 4 times 3 is 12, times by 6 would give us 72 centimetres cubed. Done. Then our next one, we would have done 8 times 2 times 3. So 8 times 2 is 16, times by 3, which is 48 millimetres cubed. And then our last one, 5 times 5 times 5 would be 125 centimetres cubed. So that, well done if you got all of those, is calculating volume. Now we might have problem questions like this. So let's have a go at this. A nursery is building an interactive water play centre for their children. The measurements of the water play centre are shown below. Calculate how many litres of water are needed to fill the play centre if 1 metre cubed is equivalent to 50 litres. So first we need to work out the volume. And as we know, we do that by multiplying the length times the width times the depth. So 4 times 2 times 0.5, which is 4 metres cubed. And then step 2 is to calculate the litres. So here we know 1 metre cubed is equal to 50 litres. So if we've got 4 metres cubed, we've timesed this by 4. So we've got to do the same to the other side. So 4 lots of 50 would be 200 litres. And that is our answer. So we know that 1 is 50, so we multiplied it by 4 to get what 4 meters cubed are, and our answer is 200 litres. Hey, our last question today. So Jenny wants to fill a sandpit in her garden. The sandpit is 5 meters long, 3 meters wide, and 2 meters deep. Bags of sand are sold in 10-kilogram bags and fill 5 meters cubed. Each 10-kilogram bag costs £12. How much will it cost for Jenny to fill her sandpit? Right, so first we've got to work out the volume. So we've got our 3 measurements here. So we're going to do 5 times 3 times 2, which is 30 meters cubed is our volume. Now we know that bags of sand are sold in 10-kilogram bags and fill 5 meters cubed. So we need to work out how many 5 meters cubed are in 30. So how many 5s are in 30? It would be 6. So we'd need 6 bags. So we need 6 bags. Each 10-kilogram bag costs £12. So now to work out the cost, it would be 6 times 12, which would be £72. And that is our answer. So today we have covered units of mass, capacity and length, converting units of time, calculating perimeter of 2D shapes, including compound rectangles, calculating area of 2D shapes, including compound rectangles, and calculating volumes of cubes and cuboids. So all you need to go off and do now is to come watch the video back if necessary, make any revision notes that are required, watch the video back, pause it if there's any areas that you want to recap, and then complete the homework worksheet. Thank you for attending today.